A cyclist heading east through a small town accelerates at a constant 4 meters per second squared after he leaves the city limits. At time t equals 0, he is 5 meters east of the city limits signpost, while he moves east at 15 meters per second. A. Find his position at velocity t equals 2 seconds. B. Where is he when his speed is 25 meters per second? So the first step to any board problem is drawing a diagram. This will help us better understand the problem and help us to identify the values we need to solve for. So we can start by drawing our origin position, then we can draw our position at time equals 0. And the question says at time equals 0, the acceleration is 4 meters per second squared, and the initial position is 5 meters relative to the origin. So we can also draw a second position at time equal to t equals 2 seconds. And we should also note that they give us the initial velocity equal to 15 meters per second. The question gives directions referring to the compass coordinates, so I just thought it'd be useful to put that. And they also say at the origin there's a sign, so I just put that there. It's helpful to put those there just to illustrate the situation better. So step 2 is always to identify what we're solving for. So in part A, at time equals 2 seconds, they want the velocity, and they also want the x position. And then in part B, they want the x position when the velocity is 25 meters per second. So now that we know what we're solving for, the next step is to identify the equations needed to solve. So we're going to need 1, the position equation, and we're going to need 2, the velocity equation. So now that we have all this information, the last step is always just to solve. So for part A, we can redraw the diagram just to help us navigate how to solve. So I'm just going to redraw it here with the values that we have. And I just want to note that what we're looking for is the position and the velocity at t equals 2 seconds, as we can see in the diagram. So we can start with the position. We can use the position equation, and they give us these values here for the initial velocity, acceleration, and the position. So we can plug these values into the equation, and we get this expression here. So then we can start doing some of the calculations. So 15 meters per second times 2 seconds, 30 meters. I just want to note that for the units here, meters per second times seconds, the seconds cancel, just leaving us with meters. And then for the second term, we have 2 seconds squared. So that ends up being 4 seconds squared, because you have to square the units and the 2 in the brackets, so that's how we get that. And then that leads us into this expression here. And then we can evaluate this term by first doing the amplitude. 4 times 4 equals 16, then times 1/2 equals 8. And then we can multiply the units, which is meters per second squared times seconds squared, and seconds squared is canceled, just leaving us with meters. And then we can just add up all the meter values, and we get the final answer. Notice how all the units make sense. We're adding all in meters, and we get the final answer equal to 43 meters. So that's going to be his position at t equals 2 seconds. And this video is getting a little bit long, so we're going to continue this question in the next part. Feel free to comment any issues you have so far.